Okay, so we're moving on, and we have here the start of presentation number 2. And after that, so your first set of examples here, it talks about simplifying expressions. This is part of the learning that we've had, how to simplify. So what we're doing is we see problems like problem A here. It says 7 times w to the negative 4th power. The first thing you want to notice is that if you break these apart, it's 7 times w to the negative 4th power is what that means. So I pull the coefficient out from the variable that's attached to the exponent. Here, the first thing I notice is I have a negative exponent. So with this negative exponent, I automatically remember I have to do 1 over this whole thing, w, and instead of to the negative 4th power, it's the positive 4th power. Now, that still gives me a 7 over here. So I have 7 times 1 over w to the 4th power. Can I multiply these out? Yes, I can. Actually, every whole number can be made a fraction by putting it over 1. So 7 times 1 is 7. 1 times w to the 4th power is w to the 4th power. This is your final answer for this problem. Now, if you notice, the 7 was still there, and I literally put the 7 over this whole thing, but a positive exponent. When you see that, for an example, if you had 9 to the negative 2 power, I'm sorry, let me do that again. 9x to the negative 2 power, you could use the same general rule and put 9 over x to the positive 2 power. That's a very quick tip that works whenever you see it written exactly in this format.
So instead, I got a question. Don't the top number always stay the same? And the bottom number change?
Okay, the top number is going to stay the same as a general rule when you see this written like this, a coefficient and a variable with a negative exponent. Okay, so if you can remember that way, then yes. Okay? So I want to move over here to part B. Part B looks very crazy because not only do I have a negative 5 in the numerator, it's over k to the negative 2nd power, so you have a negative exponent in the denominator. Remember that you cannot simplify, it is not simplified if you have a negative exponent anywhere. So in order to simplify this, the first thing I notice is I have negative 5. So I'm going to keep the negative 5, okay? When you get to this k to the negative 2 power, it's like saying negative 5 times 1 over k to the negative 2 power. So what I did was I pulled these apart. So now what's happening is I have to figure out how would I solve this? Well, remember, when you have a negative 2 in the denominator, you can work backwards. Just like we worked forward over here, we did 1 over. If you notice, this is a 1 over. You just work backwards, take the whole term, and this time you're going to drop the negative. So the common theme is drop the negative when you pop it back up into the regular numbers, or drop the negative if it's negative and you're putting it down in the denominator. So that's a common theme, drop the negative. Okay? So that actually just means k to the 2nd power. So you literally have negative 5 times k to the 2nd power because we worked backwards to get the negative out of the denominator, which makes your final answer as negative 5k squared. So the tricky part in this one was having the negative exponent in the denominator. We just brought it up, dropped the exponent to k squared, and attached our current numerator to it. So if you needed an example, anytime you see it like that, for an example, if I had 3 over x to the negative 3 power, I can use that exact same rule. I can take the 3 times, take the exponent out of here, and now it's no longer in a denominator, x to the 3rd power, 3x to the 3rd. So that would have been like saying the negative 5 k to the second as a general rule, if you can remember the visual of how that looks, if you're a visual learner like that, okay? Going on to the next slide. This one I'm going to slow down, and hopefully we get through this slide and maybe one more, and we'll be finished with this section. So I pulled this slide out for you, and I left a box for you to follow along, okay? Because there's a few things that I want to make note of. This one is a very unique problem, but you will see stuff like this not only on assignments, but on assessments and tests, and I'm sure at the end of course exam we'll have something like this, where you have multiple parts in a numerator, multiple parts in a denominator, you've got some negative exponents going on, zero exponent going on, and they want you to give them a final answer. This kind of math can be a little bit tricky because it's not really making full sense. You just have to know what's the process to get through it. So here's one of the easiest ways to figure out the process here. I want to deal with this top numerator first. The first thing I notice here is an a to the 0 power. Well, anything to the 0 power is going to equal to what? 1. Excellent, excellent. So I know that a to the 0 power equals 1. The other thing I notice here is I have b to the negative 2 power. Well, b to the negative 2, b to the negative 2 power, what would that equal? Let me write it this way, b to the negative 2. Whenever I see a negative exponent, what do I have to do? 1 over, yes, so 1 over b to the second power. Okay, 1 over b to the second power. So I dealt with that. Here, I notice, so I'm going to deal with the denominator. I'm just going to put that there. I have c to the negative 3rd power. So c to the negative 3rd power, how would you, but notice it is in the denominator. If I have c to the negative 3rd power in a denominator, I need to do reverse. Pull it out of the denominator, put it into the numerator, and I make it positive. So that's actually c to the 3rd power over 1. Because remember, anything, if you put it over 1, this shows me that it's not in the denominator anymore. And then we just have a d to the 6th power. There's no negative there, it can stay just like that. Now that I've looked at each part of it and made a note off to the side, they're equivalent, I'm going to go ahead and start putting this together and making sense of this problem. I'm going to switch to a blue marker. Well, in my numerators, I'm going to write over here, I have left a to the 0, which is 1, like we said. That's still in the numerator. But my b to the 2nd, if you notice, now I have a 1 in the numerator and a b to the 2nd in the denominator. So I'm going to record that now in my denominator. I took care of this and I took care of that. So originally I had c to the negative 3rd in the denominator, but what I did was I pulled it out to make it c to the 3rd is now in a numerator. So up here I put times c to the 3rd, because I need to list what's going in numerator, what's going in denominator. So that handles this term, and d to the 6th is still there. That's an okay term to work with, okay? So that's how they got this over here. When you see in your notes, well, I don't understand. How is the c on the bottom and now the c is on the top? Well, when you had a negative 3 in the denominator and you pulled it out to make it no longer a negative exponent, it became c to the 3rd over 1. Okay? So now that put it up in the numerator. Now I can just do this math out. 1 times c to the 3rd is c to the 3rd. 1 times anything is itself. And b squared times d to the 6th is just recorded over here. This is actually your final answer. These are a little bit tricky, and so I always want you to just stop, pull stuff out, and then line them back up, what goes where. Okay? Once you have that written down, I think you have one more example. Okay, so I'm going to move forward to the next example, okay? Here we go.
I'm so lost. I don't even have right now.
Go to this one. So when I work out this, simplify, I notice. So I'm going to rewrite it. It's 2 times r to the 0 power times m to the negative 3 power. The only thing I did was I separated each part of my term. So I pulled the coefficient out, the first variable with an exponent, the second variable with an exponent. When I do that, the 2 will just stay the same. Now r to the 0 power, what is r to the 0 power or anything to the 0 power? 1, good job. So that's just a 1. That's not hard so far. And then m to the negative 3. As soon as I see a negative power, I have to do what? Say it again. Nope. 1 over. This is the part we got to catch for the week. As soon as you see a negative exponent, you automatically are going to make a fraction 1 over whatever it was. Eliminate the negative exponent. So 1 over m to the third. So m to the third power. Before you had m to the negative third, now it's m to the positive third, but you had to put it under 1. You had to put it in a denominator. So when I multiply these out, 2 times 1 is just 2, and that times 1 over m to the third. How do you do that technically? 2 goes over 1. 2 times 1 is 2. 1 times m to the third is m to the third. So this is your final answer. 2 over m to the third power. You can have an exponent in the denominator. You cannot have a negative exponent in the denominator. Okay? So don't let that trip you up. Over here, r to the negative third power automatically becomes 1 over, I'm going to write it over here, 1 over r to the third power. Okay? When you have something like that divided by 7, it's actually, when we do this, we have to time. So by throwing this down here, we're actually going to multiply. So you still have a 7 down here. So actually you have 1 over 7r to the third power. The 7 stayed underneath. The r to the negative third became r to the positive third, and the whole thing was over 1. Close the door. Now over here, we see a negative in the denominator this time. Remember, when the negative is in the denominator, we have to put it up into the numerator, rewritten without the negative exponent. All right? So now it's no longer in the denominator. So now I have g to the 4th times h to the 6th, which literally is just g to the 4th, h to the 6th. So actually we eliminated the negative sign and we just multiplied those two terms by each other as your final answer. I hope you're getting the process for how to solve these. They are tricky. Sorry?
What were you multiplying?
Say it again.
What were you multiplying?
Sure, let me go backwards here. So the reason we multiply, when you're bringing this up to the numerator, or even over here, bringing this down to the denominator, see how that became r to the third? This became h to the 6th. Whenever that happens, it's going to be multiplied by whatever was there. Just like here, it'll be multiplied by whatever was there. That's the general rule. So it's whatever was there. So g to the 4th was there. Now h to the 6th is there. We're going to multiply those. Because they are not like terms, they just get listed next to each other until they become solvable at some point. Can you see, does that help you? Okay. Any other questions on this part? So that's the end of presentation station 2. What you can do is go on, finish independent learning station 1, which was the reading strategies worksheet, Or if you did that, you can go ahead and work on your independent station, workstation 2, which is a textbook assignment which pulls together all of the learning we've done this week, along with the addition of doing simplifying expressions like this. I'm available to help out at any point, just ask for help.